Hello everyone and welcome to 30 days of DSA challenge, where we will be solving a DSA problem every day for the next 30 days. So this is our day number 9, where we will solve a problem based on stack, and the level of this question is going to be easy. The name of this question is valid parenthesis. You will get this question link in description, and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So this is our question on LeetCode. It says that given a string S consisting just the characters, so our input string will only have these characters, determine if the input string is valid or not. So we have to determine the input string is valid or not. We have to return true if it is valid, or we have to return false if it is not valid, right? And an input string is valid if open brackets must be closed by the same type of bracket, open bracket must be closed in the correct order, and every closed bracket has a corresponding opening bracket of the same type. So these are some rules which determines how we can say that any input string is valid or not. So we will analyze this. So let me just explain you this by taking some examples. Okay, so in the question it was clearly mentioned that we will have 6 type of characters into our input string. It can be a opening parenthesis or a closing parenthesis. It can be a opening square bracket or a closing square bracket, or it can be a opening curly bracket or a closing curly bracket, right? Now these are the 6 type of characters which we can have into our input string. Or you can also say that we will only have 3 type of brackets, right? We will only have 3 type of brackets into our input string, right? Into our input string. Now let's see what they mean by valid, right? What they mean by valid. So if I take this example, let's say that this is our input string, and let me write the indexes. The indexes are 0, 1, 2, 3, 4 and 5, right? So here you can see that for this particular opening parenthesis we have this closing parenthesis, right? So we can say that it is balanced, right? It is balanced, right? We can say that this is balanced. Similarly, for this opening a square bracket we have this closing square bracket, so it means that they are also balanced, right? And similarly, for this opening curly bracket we have this closing bracket, we have this closing curly bracket, so we can say that this is also balanced, right? So we can see that for all opening brackets we have the corresponding closing bracket. That means it is a valid, right? It is a valid string, or we have to return true for this particular case, right? Let me take some more examples. So let's say our input string is something like this, right? Our input string is something like this, and these are the indexes, right? So here also we can clearly see for this opening parenthesis we have this closing parenthesis, right? So we can say that they are balanced, right? They are balanced, right? They are balanced. Similarly, for this opening square bracket we have this closing square bracket, so we can say that they are also balanced, right? They are also balanced. Similarly, for this opening curly bracket we have the corresponding closing curly bracket as well, right? So we can say that they are also balanced, right? They are also balanced. So we came to a conclusion that for every opening bracket, whether it is a opening curly bracket or it is a opening square bracket or it is a opening parenthesis, we have the corresponding closing brackets, right? So it means that this is valid, or you can say that this is a valid input, right? This is our valid input. So we have to return true, right? We have to return true. It is balanced, right? Now let me take some more examples. So let's say we have this input string, right? We have this input string, right? Okay, we have this input string. So here, and the indexes are 0, 1, 2, 3 and 4, right? So here we can clearly see that for this opening curly bracket we have this closing curly bracket, so we can see that they are balanced, right? It is balanced. Okay, for this opening square bracket we have this closing square bracket, so we can say that it is also balanced. But here we have a closing parenthesis, and for this closing parenthesis we do not have any opening parenthesis in our input, right? For this closing parenthesis we do not have any opening parenthesis in our input, so we can say that this is not balanced, right? This is not balanced. And if any bracket is not balanced, then we can say that this our input is not valid, right? It is not valid, and if it is not valid, we have to return false, right? We have to return false. Okay, now let's take one more example. Let's say we have this, right? We have this as an input, right? And the indexes are 0, 1 and 2, right? So here we can clearly see that for this opening square bracket, we have this closing square bracket. So we can say that they are perfectly balanced. They are perfectly balanced. But for this opening curly bracket, do we have any closing curly bracket in our input? So the answer is no. It means that this opening curly bracket, this is not valid, right? This is not valid. If any bracket is not valid, right? If any bracket is not balanced, then it means that the input string is not valid and we have to return false in that particular case, right? So I hope now it is clear what do we mean by balanced parenthesis or valid parenthesis. Now let's think of how we are going to solve this problem. So now for solving this problem, we will use a stack, because it is a traditional stack problem, and I hope you are familiar with stack. I hope that you know how the stack works. It works on the principle of last in first out, right? Last in first out. So anything which goes into a stack last, right, it will come out first, right? And anything which will go into a stack first, it will come out at the end, right? So this is the property of a stack. Now let's take this example. Okay, yeah, this is our example, and the indexes are 0, 1, 2, 3, 4 and 5, right? And we are using a stack. So let's say this is our stack. So initially what we will do, we will run a loop into our this input string, right? And okay, so let's do this. So let's say our I is not here. Let's say okay, our I is firstly at index number 0. So we will firstly check which kind of bracket it is, right? Is it a opening bracket or is it a closing bracket? So we saw that it is an opening bracket, right? Now it can be of any type, right? It can be a curly opening bracket, it can be a square opening bracket, or it can be opening parenthesis, right? No matter if it is any kind of opening bracket, we'll just put it into our stack. So what I'll do, it is an opening bracket, so I'll put it into my stack, right? I will put it into my stack. Okay, and after that I will increment my I. So now my I will come at index number 1. So here also at the index number 1, we can say that it is an opening square bracket. Now as it is an opening square bracket, I will put it into my stack. I will put it into my stack and then I will increment this, right? Then I will increment my I. So now my I will come at index number 2, right? Now here it is an opening parenthesis, right? Or you can say that it is a kind of opening bracket. Now if it is an opening bracket, what we have to do, we just need to put it into a stack. So I'll put it into my stack, right? Then I will increment my I. Now my I will come at index number 3, right? And at the index number 3, you can clearly see that here we have a closing bracket, right? Here we have a closing bracket. Now, whenever we get a closing bracket, we will ask our stack that for this closing bracket, do I have the corresponding opening bracket or not, right? So as we know, the stack works on the property of last in first out, right? It works on the property of last in first out. So this was something which was entered at the last. So it will be taken out from the stack first, right? It will be taken out from the stack first. So we will take this. We will take this, right? We will take this out. And now we will compare, right? Now we will compare that are they of the same type? Yes, they are of the same type. And for this is the closing bracket, and for this we have this corresponding closing bracket, right? This is the corresponding closing bracket. So what does it mean? It means that for this opening bracket, we have this closing bracket, right? They both are of the same type. So what does it mean? It means that it is valid. It is valid, right? It is balanced. Now if this is balanced, then what we have to do, we just have to take it out, right? We have this here, and we will take it out from our stack, right? We will take out from our stack. So now my stack will look like something this, right? And after this, what I'll do, I will increment my I. So now my I will come at index number 4. And at the index number 4, again we have this closing bracket. Again we will do the same thing. Whatever is present at the top of our stack, we will take it out. So what it is this, right? It is this. Okay. Now we will check. For this closing bracket, is it the corresponding opening bracket? You will say yes, definitely. Yes, definitely. For this closing bracket, this is the corresponding opening bracket. It means that this closing bracket and this opening bracket are perfectly balanced. They are perfectly balanced. Now, if they are perfectly balanced, then what we have to do, whatever present at the top, whatever was present at the top into a stack, we will take it out from our stack. We will remove it from our stack, right? We will remove it. So I will remove this, right? Now what I'll do, I will again increment my I. So now my I will come at index number 5. Here also we have one closing bracket. Here also we have one closing bracket. Now I will again check what is present at the top, what is present at the top of my stack. So it is this, right? Now I will check for this closing bracket, is it the corresponding opening bracket or not? So you will say definitely yes, for this closing bracket, this is the corresponding opening bracket. Now what does it mean? It means that this and this, they both are perfectly balanced. Now if they are perfectly balanced, then what we will do? We will take this out from our stack, right? We will take this out from our stack, and now we can see that our iteration is completed. Our loop is completed. Then we will check our stack. Is it empty or not, right? Is it empty or not? If it is empty, we will return true, return true, which will say that the input is valid. If it is not empty, then we will return false by saying that the input is not valid. So here we can clearly see our stack is empty. It means that the input is valid and we will return true, right? So I hope you got the intuition, you got the idea. So let me take just one more example and then we will move on the coding side. So let's say we have something like this, right? We have something like this in the input and the indexes are 0, 1 and 2, and this is our stack. Okay, so what we will do, firstly we will run a loop in this our input stack, in our input string, sorry. So firstly our I will be here. What it is an opening bracket, so we'll put it into our stack, right? And then we will increment our I, right? Our I will go to the next index. Okay, now what it is again an opening bracket. So we'll put it into our stack. Right? And then we will move our I. So now my I will come at index number 2. Now what it is a closing bracket. So I will say okay, whatever present into our stack, what is present at the top of our stack? So it is this opening curly bracket. Now I will compare for this closing bracket, is this the corresponding opening bracket or not? So you will say yes, for this closing bracket, this is the corresponding opening bracket, right? And if this is the case, what we have to do, what we were doing till now, what we'll do, we'll just take this out. I will remove it from my stack, right? So now I will remove it. Now my I will increment again, and now we are out of our loop, right? We are out of our loop because we have completely traversed the input string, right? Now after, at the end of the loop, we will check, is my stack is empty or not? So here we can see that our stack is not empty. It have a opening bracket. It means that this input is not valid and we will return false. Right? And you can clearly see that. For this opening bracket, we have this closing bracket, so they are balanced. But for this opening bracket, we do not have any corresponding closing bracket into our string. So this particular thing is not balanced, right? This particular opening bracket is not balanced. Therefore, we will return false, right? So I hope it is clear. And if you have any doubt, then please do dry run by taking different examples. Now let's think about how we are going to code it. So coding is very simple. We will be using a stack of character type. It will store different characters and the name of the stack is st, right? And we will run a loop. So let's say we are running a loop from I is equal to 0 up to n. And what is this n? This n is nothing but the size of our input string. And let's say the name of our input string is str, right? It is str. Okay. So now what we'll do, firstly we have to check is if it is a opening bracket or it is a closing bracket, right? So if it is a opening bracket, so we'll check it like this. If the str of I is equal to this, right? Or the str of I is equal to the opening square bracket, or the str of I is equal to the opening curly bracket, right? If this is the case, what we have to do, we just need to put it into my stack, right? I need to push it into my stack. So the name of my stack is st, so I'll write st dot push, let me just write it again. Yeah, st dot push str of I, right? Str of I. Okay. Else, if this is not an opening bracket, then what we have to do? So it is very simple. If it is not an opening bracket, then it is going to be a closing bracket, right? It is going to be a closing bracket. So firstly we need to check, is our stack is empty or not, right? We need to check our stack is empty or not. So we will write if st dot size is equal to 0. If the size of the stack is equal to 0, it means that it is empty. Or if it is empty, then we will return false. Now you might ask me why you are writing this statement. So let's take an example. Let's take an example. Let's say we have an input like this, right? And the indexes are 0, 1 and 2, and this is our stack, and this is our stack. Okay. So see, when we'll run a loop, firstly my I will be pointing at this index number 0, and what it is a closing bracket. So I will check for this corresponding closing bracket, do I have the corresponding opening bracket into my stack or not? But we can clearly see that into our stack we have nothing. Our stack is empty. What does it mean? It means that we are getting a closing bracket without having an opening bracket, right? We are getting a closing bracket without having an opening bracket. And if we are getting a closing bracket without having an opening bracket, it means that this is not valid. This is not balanced. Therefore, we will return false, right? So I hope this particular thing is clear to you, right? Okay. Now, if this is not the case, right? If our stack is not empty, then what I'll do? I will see what is present at the top, right? What is present at the top of my stack. So how I will get it? I will write char ch is equal to st dot top. Okay. Now whatever is present at the top of my stack, is now in this particular variable ch, right? Okay. Now if it is a closing bracket, then I will check which type of closing bracket it is, right? So I will write if the str of I is equal to a closing parenthesis, right? If this a closing parenthesis, right? Then what I have to check? I have to check that whatever present into my at the top of my stack, should be opening parenthesis, correct? To be balanced, if we are having a closing bracket of this type, right? And in the top of my stack, if I have this opening bracket, it means that it is valid. Else I can clearly say that it is not valid, right? So I hope it is clear to you. So I will write if ch is equal to this, right? If ch is equal to this, it means that it is valid. Now if it is valid, what I have to do? I just need to take it out. I need to remove it from my stack, right? So I will do st dot pop. Very clear, right? Else what I'll do? I will simply return false. Right? For example, if we are getting this closing bracket, right? And at the top of our stack we have something like this, right? So we can clearly see that this is not valid, right? The case of being valid is if we are having this closing bracket, then we should only get this opening bracket, right? We should only get this opening bracket if we have this closing bracket. If this is the case, it means that it is valid, and just take it out, remove it from my stack. Else if we have anything else apart from this, we have to return false. By saying that this is not valid. Similarly, we have to write for the other opening brackets as well. For example, if the str of I is equal to an opening square bracket, then I have to check that my ch should be equal to this, right? Okay, I'm sorry, I just wrote it reversely. So if the str of I is this, right? If this is a closing square bracket, then I should have the opening square bracket at the top of my stack, right? If this is the case, just do a pop operation. Else just return false, right? I hope this is clear. Similarly, we will do the same thing for our curly closing bracket as well. So now if the str of I is equal to this, right? If this is a square curly bracket, then the ch, right? The ch variable, this ch variable should be equal to this, right? If this is the case, I will do st dot pop. I'll do st dot pop. If not, then I will simply return false, right? I will simply return false. And in this way, my for loop is going to end, right? And in this way, my for loop will end, right? And at the end, what I'll do, at the end, I will check that if st dot size is greater than 0, right? Or we can say that it is non-empty. So I can also write it in a different way, right? I can say that if st is not empty, right? If it is not empty, then return false, right? Or if it is empty, else if it is empty, then return true, right? Then return true. So this is the simple code. I hope the code is clear, the intuition is clear. Now let's talk about the time and space complexity. So the time complexity is very simple. It is going to be of O of n because we are running a for loop, right? And the space complexity is also going to be O of n because we are using a stack, and at max our stack can be of size O of n, right? So now I hope the intuition pseudocode is clear into your mind. Now let's code it up fastly on LeetCode. Okay, so here we are on LeetCode. Now let's just code it up fastly. Okay, so what do we need? We need a stack of character type, right? We need a stack of character type, and let me name it as st. Then we will need the size, so I'll write int s is equal to s dot size, because here the name of our string is s, right? The name of our string is s. Then I will run a for loop, int I is equal to 0, I is lesser than n, and I plus plus. Okay, so firstly I need to check, is it opening bracket, right? I will check, is it opening bracket or not, right? So it can be any type of opening bracket, right? So I need to check it. So if s of I is equal to opening parenthesis, or s of I is equal to opening square bracket, or my s of I is equal to opening curly bracket. If this is the case, then what I have to do, I just need to put it into my stack, right? So I will do st dot push, I'll do st dot push s of I, correct? This is something which we'll do. Okay, if this is not the case, it means that it is a closing bracket. It is a closing bracket. So firstly I need to check my stack is empty or not. So I'll write if st dot size is equal to 0, it means that it is empty. Now if it is empty, I just need to return false, right? false, false, right? If this is not the case, I will take the element which is present at the top. So I'll write char ch is equal to st dot top, right? I have it. Now I need to check that which closing bracket I have encountered, right? So I'll write if s of I is equal to a closing parenthesis, right? If this is the case, then what I have to do, I need to check that my ch should be equal to the opening parenthesis. If this is the case, I will do st dot pop, right? Else what I'll do, I will return false, right? Else I will return false. I hope this is clear. Similarly, I'll write else if s of I is equal to, if it is equal to an opening square bracket, right? If it is an opening square bracket, then I will again check the ch should be equal to the closing square bracket, right? It will be sorry, I just said it reversely. If the s of I is a closing square bracket, right? It will be closing square bracket. Yeah, it is a closing square bracket. Then I should get the corresponding opening bracket, right? If this is the case, then I will do st dot pop, and if this is not the case, then I will return false, right? Then I'll return false. Else. So it is very clear that we will only have 3 type of characters, right? We'll only have 6 type of characters, sorry. So if it is not an opening bracket, right, then it will be either this closing bracket or this closing bracket, or it will be a curly closing bracket. So I can directly write that if my ch is equal to this, right, then I need to do st dot pop, and if this is not the case, else I have to return false, right? This is what we need to do. And after completion of this, I just need to check that if st dot empty, right, I will check if my stack is empty, right, then I will return true. If this is empty, I will return true. If this is not empty, I will return false, right? Else I will return false. So this is our code. We are using a stack which is of character type. It is storing different characters, and we have n, which is the size, and then we are running a loop from I is equal to 0 up to lesser than n. And then if it is an opening bracket, no matter which type of opening bracket it is, we will just put it into our stack, right? And if it is a closing bracket, firstly we will check our stack is empty or not. If it is empty, we will return false, right? Now we will check that if it is a closing parenthesis, then we should have the corresponding opening parenthesis, right? If this is case, it means that it is valid, right? It is balanced. Then I will do st dot pop. If not, then I will directly return false, right? Similarly, I will check if it is a closing square bracket, then the ch should have the opening square bracket. If this is the case, it means that it is valid, and I will do st dot pop. And if this is not the case, that means it is not balanced, then I will directly return false. Similarly, we will come in this else block only when we have encountered the closing curly bracket, right? So therefore we are checking that if my ch is equal to the opening curly bracket, then it means that it is valid, and I will do st dot pop. If this is not the case, I will simply return false. And at the end, I am checking that is my stack is empty or not. If it is empty, I am returning true. If it is not empty, I am returning false, right? Now let's just run it up fastly. Okay, so here you can see that all the 5 sample test cases are running fine. Let me just submit this. Okay, so here also you can see that it is accepted. So this was all for our day number 9, where we solved a problem of stack, that is valid parenthesis. I hope you liked this video. This video was helpful to you, and if it was helpful to you, then make sure you like this video, make sure you comment something, and if you have any particular different approach, do comment, and make sure you subscribe to this channel so that you regularly get this type of content. Thank you so much. We will meet again tomorrow with the next question.